Okay, class, we're going to get started right now. How you guys doing today?
Good.
You guys are doing good?
Yes.
High five. Give me a high five. All right, guys. You guys got to be excited. You guys are going to learn a new thing today. You guys got it?
Yes.
All right, so the objective of today is going to be, do you guys know how to read this, what it says in here?
No.
Okay, what it means is students will be able to produce an equivalent system of equations.
So like the goal of the day.
The goal of the day, that's what it is, okay?
Yes.
So before we start learning something new, I'm going to ask you guys some questions. Are you guys familiar with linear equations?
Yes.
No.
Can you guys give me an example of a linear equation? I need a volunteer. Come on, Pepe. Give us an example of a linear equation. You don't know it? Anybody else?
Y is equal to x plus any random number.
Okay. X plus any random number. Let's choose B, for example.
Oh yeah, I remember.
Okay. In here, I just want to tell you that the slope of this is just 1. Are you guys familiar with the slope?
Yes.
That's good. So let's move forward. Where's my Oh, here it is. Cool. So you guys are going to be learning about equivalent system. Okay? So what it is the following. That's going to be a new vocabulary words for you guys. So if you guys could get started taking notes, and then so you guys could, write it and have an idea of what we're talking about. You guys need a pencil or a pen?
Yes.
Here's a pen. Let me get a hold of paper out here. Okay, so what I'm going to start doing right now, I'm going to start showing you 2 linear equations in a single coordinate point system, okay? Check this out. I'm just going to give you an arbitrary line, for example, starting now. Let's just call it a line L. And this is going to be line P. Can you guys tell me something that you guys see on this graph?
That the line is going across the zero. That is like that they intersect too.
Bingo. That's the word that I wanted to hear. They intersect. Okay? And that's what equivalent systems are. In other words, yes?
Do we copy this out?
If possible. So systems, equivalent system of equations, what they are, they're just lines. They intersect at a certain point. Just think about, I'm going to give you an example. For example, look. Let's say Moises and Araceli. Let's say that they live like 10 miles away from each other. And they try to meet at a point. Let me draw it for you guys so you guys can have a clearer picture of what I'm talking about, okay?
So basically, they're gonna meet in one.
Yes, that's what it is. They're gonna meet halfway or in between.
And then
So they
see what takes the most or who.
That's right. Okay, check it out. This is Araceli, and this is Moises. Okay. Their distance is 10 miles. Okay. And they probably want to meet each other, but they don't want to. None of them want to travel from one side to the other one. So they decide to meet at a certain point. Okay, to hang around, to have lunch. That's what they're doing. Just think about one of them going in a straight line and the other one going in a straight line. If they meet in between, that's where they meet. That's the point of intersection for them. You see, system of equations, it happens all over Mother Nature. It happens in our daily life. Okay? You guys have any questions?
So what we're trying to find out is like how far from each other and
No. What I'm just giving you is just an example of how systems of equation occurs.
Okay.
Okay? Another example might be something like this. How many of you guys take the bus? And you guys know that you guys gotta meet them at a certain point, right?
Yes.
What happened if you guys don't meet them at a certain point at a certain time?
And
We miss
we miss it.
Yeah.
You guys miss it. There we go. So that's another, believe it or not, that's another system of equations, that a point of intersection within time. So what I want you guys to write on your notes is the following definition, okay?
Okay.
Okay, so system of equations. And I'm going to use another color so you guys can see what I'm talking about. It's, let's define it as equations or more lines intersecting at a point in time. Okay? You guys copy that already?
Yes.
You guys understand? Raise your hands if you guys do. Good job, guys. Okay, so we're gonna do the following example. I'm gonna model for you guys an example. But before I do that, are you guys familiar with sushi?
Yeah.
Yes.
Do you guys know how sushi looks like?
Yes.
Yes. It's
How does it? Huh?
Round.
Round.
Cylinder.
Round, and then there's
That's
rice
cylinder.
inside with the.
That's right. It has rice. It has avocado.
Fish.
Fish. It's raw fish.
Tuna.
I've tried tuna. But if in case that you guys don't know how it looks like, this is how it looks. This is sushi out here.
You like it?
I love it. Love it. It's really delicious.
It's not good.
So I'm gonna pass this picture for you guys to grab an idea of how it looks. I have another one out here too that I'm gonna pass it going this way. Hey, don't get hungry, okay? Don't get hungry because they seem really good.
LOL.
Okay, so I'm gonna start doing this example. You see, about 4 blocks away from here, we have a restaurant that is called Arigato Sushi. I don't know if you guys been there before or not.
Yes.
I'm gonna pass around
Menu.
their menu that I have somewhere out here. Oh, here it is. Sorry, guys. I'm gonna pass it around for you guys to have an idea. And what they do is they sell the rolls at $3 a piece every roll. So you could order, for example, 1 roll, and you're gonna pay $3, including tax. So their prices are really flexible. Okay. So let's say that if you order 4 rolls, it could be tuna, it could be shrimp, whatever they have in their menu. You're gonna pay a single price for it, $3 a roll. That's a really good price, okay? So if you order 4 different rolls, you're gonna pay $12.
So you just keep adding 3.
So you just keep adding 3. Are you guys able to see like some type of equation out here?
Yeah.
Yeah.
What is it, guys?
It's like
It-
x
Like 1
plus
times 3.
x plus 3 equals 1.
Say that again.
X plus 3 equals 1. It's something like that.
1 times 3 equals y times 3 equals
Or 3 times x.
y times 3.
I'm gonna give you a hint.
Y is equal to
3x equals
times-
y.
2x plus the number the sushi costs.
No.
It's 3.
Y
Three.
equals.
No,
equals
it's
y.
3 times the price of sushi. I mean, I'm sorry. It's you
The
guys
number.
got me confused.
3x
The number.
equals
It's
y.
3x.
Equals y.
Y is equal to 3x. 3 represents the set price, and then x is just the number that you guys decide to purchase. So if you guys want like 10 different rolls, you guys just multiply 10 times 3, and that's going to be $30. Okay? Got it?
Yes.
Yes.
Okay, good. Okay, so moving forward, since you guys already saw the price, let's use this. I'm gonna do an example for you guys now. Okay, so you guys on the other one, so you guys could give it a try yourself to see if you guys are able to solve it. And let's say that Natalie and Becky, they decide to go to the Arigatos sushi restaurant. Okay, and that the question is, when will each person pay $9?
When they both buy.
Natalie.
When they buy each 3.
There we go. There we go. That's the right answer. You guys see? Just think about it. So you have Natalie here and Becky, okay? And the question was, when will each person pay $9? Okay? So if you think about your old, when we came out with Y
Equals 3.
3x, the way you solve it, you let $9, it's equal to 3 times
Could you also
X.
divide it?
That's right. Somebody help me out here. What do we do first?
Divide by 3. On both sides.
There we go. So this one cancels out, right?
Yeah.
So X,
Equals
Equals
3.
3.
3 sushi rolls, correct?
Yeah.
Yes.
Good job, class. You guys are doing a terrific job. Right on. Give me a high five, class. You guys are wonderful. You guys are wonderful. You guys are wonderful. Right on. Right on. Okay, so the following example is going to be a little bit more. It's going to be a little bit more difficult for you guys, but I want you guys to give it a try. And meanwhile, I'm going to be walking around to help you guys out. Okay. Please write it down, and you guys are able to talk within your groups. Okay, so it's the following. We're gonna be looking at the sushi, the prices again. So just keep that in there. And it's the following: Araceli and Pepe, they go together to the same restaurant, Arigatos restaurant. Okay. And I'm gonna write the name of Araceli here. And Pepe, okay? Araceli, what she gets 2 sodas, okay? She purchased 2 sodas. And each price of a soda, it's at $2 each. Pepe, he gets 1 tea. And the price of the tea, it's $1, okay?
Mm-hmm.
That's the price of the tea. And each person, when they go to that restaurant, they only walk in with $13 in their pockets. And that's the only amount that they're able to pay. Okay? What I'm asking you, what the problem is asking us is the following. If both decide to spend $13 each, how many rolls would each have to order in order to pay the same? In other words, how many rolls does Araceli needs to order in order to spend $13?
But is the $13 including the 2 soda that she wants to buy?
That's right. Okay. And Pepe, it's keep in mind that he only has $13, so that's the max that he's able to spend there, and that's what he wants to spend. He wants to be dineless at the end of the day, so he also wants to spend $13. Okay. So how much? Let me ask you guys a question. How much money, based on those 2 sodas that she has already purchased, has left, or how many money has she wasted so far?
$4.
$2. $4 which she
$4 with
Okay.
just the sodas.
$4. Okay, that's good. $4. Okay. What about Pepe?
$1.
$1. That's good. You had a question, Jonathan?
I already found out the answer.
Me too.
Okay.
For Pepe.
Okay, for Pepe.
He's gonna buy 4 rolls.
Okay, let's see 4 rolls out here.
4 rolls.
And Sally is 3 rolls.
Yeah.
3 rolls, okay. Any other suggestions that you guys might have? No. Now let's look at the answers, and I have to give you guys an insight. You guys probably already know how to solve it. Any of you guys didn't understand how to get the rows, the 4 rows? Okay, so the way we solve this is, I mean, you guys already got the answer, but the way that we could approach this is this. Look, so far, Araceli, she has spent $4 already, okay? I'm going to use another pen or marker. It's $4. So, she only has $13. So we subtract it. 13 minus $4
Equals 9.
equals 9, okay? What about Pepe out here?
4 minus 1 equals 12.
13 minus
13
1.
I mean,
13 minus $1
12.
is equal to $12, right? So, Pepe, Araceli, she only has $9 to spend. Pepe, he has $12 to spend. Okay? So, if we look at our number, the Arigatos prices, what's out here, guys?
$9.
For 2 rolls.
For 2 rolls.
There we go. What about Pepe?
$12.
$12.
For 4 rolls.
4 rolls. There we go. You see? That's how... You had a question, Natalie?
No.
Okay, you see, that's how equivalent systems of equation work. That's the application that we're able to give into mathematics. Sometimes, for example, when you walk into a store, you only have a certain amount of money, and you want to match what you purchased about a year ago in order to last you a little bit longer on your freezer. That's an example. Just think about it that way, okay, class? Now, you guys are going to do a problem right now.